Hey guys, it's Vince. Today in this video we are continuing with yet again part 11 of the series of once again CNC router controllers built incorrectly. In this video we'll just continue it going, guys. I'm getting a lot of feedback, so there's no reason to end this series. You guys want to see the content, I'm definitely going to put it out there. Let's jump right in. This is an interesting one.
Now, as I mentioned earlier, my machine, like most, uses stepper motors. I chose to go with NEMA 23s. NEMA is a standard motor profile size. The cross-section on all NEMA 23s, for example, is the same, but you can get different lengths, with longer models usually having more torque. So obviously, I went with the most powerful one I could find, 425 ounce inches, because I didn't know how much I actually needed, so I figured the more the better. I bought a kit from Stepper online that had 3 motors.
Okay guys, this is really interesting to look at because we've never really looked at some of the kits that come from overseas. You can see here, he just arbitrarily went online, grabbed what he thought would work, and this is what many end users do. And let's break things down. We can see we're getting 7 components here for $165.76. Now, how I do math when it comes to packages like this, like many of you I hope do math with it, is I would just divide how many components I'm getting versus the total. Now, we don't know what he paid for shipping. It's kind of arbitrary. I'm sure it's not much. But if we break this down at $165.76, we're going to do it without the shipping. We're going to say you're at $23.68 per component. Now, what I want you to really think about is what kind of quality are you getting for $23.68 a component. Now, of course, I'm not saying you can't get great quality from overseas or other venues in the world. What I am saying is that with that degradation of price, you're going to be getting short somewhere. And usually, it may not just be the quality of the components in which I'm talking about support. And that's why when you look at these kits, there is no real information regarding the system build. Why? Because it's going to take them more time to do that. Are they selling the correct accessories to go with this? No, they're not. Because China is a factory, and we all know that that's where these kits come from, and we understand, or should understand, that they are putting kits together to entice you to buy. They are not putting kits together that are engineered so that your success is in mind. Think about what I just said there. They are making it look really sweet to purchase these components and make it so that the average person sees this and says, man, that's a great price. I can beat all the other prices in the U.S. I'm jumping on. And then the second that guy has a question, he is SOL because he finds out that they're not willing to answer or they're not providing the support required for him to move forward with what he purchased. Why? Because he essentially went to Home Depot and bought a toilet and he thought he was going to call Home Depot and ask them how to install it as a plumber would. Be real, guys. Be real. You will pay more with me, but you will get what you pay for.
There's 3 drivers and a 36-volt power supply.
Once again, guys, just to reiterate, I just discussed that the breakdown of what components are included with the kit do not have any discussion on the required remaining components, and you can see it for yourself right here.
Unit. With the motors installed, it was time to start wiring up the electronics. Now, as I mentioned earlier, the motors are controlled by driver boards, but there has to be some kind of intermediary control board that translates and distributes commands from the computer. Enter the Arduino Uno. The reason I chose this for the control board is that the units themselves are very cheap.
I know many of you, like me, are seeing a huge pattern with what's being shown in all of these videos in the CNC failure series, and that is that most problems are driven around the USB controllers, namely Arduinos, and he goes into other reasons why he chose this controller. The number one reason, of course, is that we know it's cheap. The reason it's cheap, it was never designed around being used for precision CNC robotics. And for some reason, this keeps on being overlooked. If you use this controller, be aware that you are liable for stability problems with signal reception and EMI, and this is proven none other than Balzis once again with his email. I want you all to read what it states. And CNC drive manufacturers in Hungary, some of the best CNC controllers, and if they're having trouble with their UC100, in terms of stability. What do you think is happening with a board not even designed for CNC use?
The firmware that runs on it is free, and they're pretty easy to get set up and running. Before I could finish wiring everything up, I needed some sort of case that I could put all the electronic components into. I wanted to design it in such a way that I could easily disconnect it from the machine in order to more easily change out parts if I needed to. I found an old DVD player for sale that had a nice metal enclosure and a working 12-volt power supply inside. I gutted everything out of the box except the power supply. I then figured out where everything needed to sit and drilled some holes to start mounting all the new parts. In order to create the panel that would house the plugs for the cables that went to the machine, I made a small aluminum plate that would mount in the open area of the box that was left vacant when I removed the DVD drive. Into this plate, I mounted 6 female end.
Okay, once again, he did a great job with his movie editing skills where he goes in and does the transition, shows the connectors going in. Unfortunately, he made the mistake of saying that these connectors are female. These are male connectors, gentlemen. I get told that a lot. There seems to be a lot of confusion between male and female connectors. I will bring them up on screen so you can see the difference between a male and a female connector. Think of the male body and the female body, guys. It's that simple. Anything that has a physical extension, meaning a pin, will be a male connector. Anything with a hole is a female connector.
4-pin connectors, as well as an on-off switch and a single barrel jack power connector. 3 of the 4-pin connectors were for the motor cables.
Okay guys, once again he's providing incorrect information. You should be using a GX16 5-pin connector on all of your motor cables so that your motor cables, number one, are double shielded and have a place to allocate the shield drain to. When you plug in your female end of the cable into your male panel mount that's installed in the rear enclosure's backplate, meaning your electronics enclosure, it will allow a terminal to be properly ground drained to the bus bar mounted inside your electronics enclosure. That is the proper way to dissipate EMI, if any is present on the motor cable. Now, what he shows, he doesn't even really discuss what gauge cable he's using, which is also imperative to really pay attention to, because if you provide too small of a gauge cable, and a lot of guys do based on price, you are at risk of signal degradation due to voltage drop-off. And if you don't believe me on that, Google the term. You can read for it yourself. That's why understanding the maximum length you can go with a stepper or servo is imperative, and I would never exceed 30 feet.
I installed the 36-volt power supply, the 3 drivers, the Arduino, and a small opto-isolator board for the switches. I also connected some small fans to the secondary power supply to keep all the electronics cool. Okay, I realize that wiring job is far from pretty, but give me some slack. It was my first time. I better explain how all this mess works.
Okay, I have to say how ironic it is that he would ask us to cut him some slack because his wiring is messy and this is his first time. Yet then he goes into a spiel about explaining how the electronics work, which we already see a lot of problems with what he's done. A lot of these guys do this. I see it time and time again. They, once again, like to explain components in basic format because they can identify them easily. When it comes to understanding the theory around the build and the proper electronics to use to support those components that they understand, that's where they're lost. You will see that in all of the videos I have in series.
For each motor, there is a step, direction, and enable input, each controlled by the Arduino. The enable inputs are all tied together since obviously we want them all enabled. The step or pulse pin tells the motor to take a step, and the direction pin tells it which direction to turn. Each driver has a power input coming from the 36-volt power supply, and 2 power output lines going to the 2 different phases of the motor. These 4 wires are what go to the connector plugs at the front of the box. The limit switches are also connected to the Arduino and tell the machine when it has reached its home position, as well as serving to prevent it from moving beyond its physical bounds.
Okay, once again, we stop his tutorial so that we can provide a more in-depth look at what he's discussing because, of course, he did just what I said and broke down basic components in that he understands how a switch works. Now we're going to get into more theory around why so many systems have problems. When you run, like he has here in his image, a proximity/home switch, whatever you want to call it, right near a spindle/wood router which he purchased from Home Depot, which was never designed to be used for robotics use, in proximity to that, you are at high risk of EMI penetration because those low voltage components were never designed to be run without double shielded cable to properly dissipate any potential EMI that would be present. Now, the thing to keep in mind, guys, when I tell everybody that these wood routers are not designed for robotics use, they generate more amperage based on friction. If you're cutting at a faster feed rate, you generate more friction. If you're cutting at a lower feed rate, you generate less friction. But the bottom line is, any hiccups during cutting with that spindle motor or / router motor, you're going to have fluctuations in amperage, which creates fluctuations in EMI. If your chassis is metal, like so many of them are, it's basically an antenna for that EMI. And where does all that energy go? To any of those low voltage components, and it will cause corruption. Now, he would know that, pending he did a little Google research. The other thing to keep in mind is that a box store wood router does not come with the proper double shielded cable. And many of you were saying, well, a CNC spindle doesn't either. That's right. It doesn't, because the end user is to supply the proper cable in terms of double shielded and the correct length.
I wired these through the aforementioned opto-isolator circuit with the hope that it would eliminate some of the noise from the switch wires.
Okay, guys, once again, he is providing misinformation. What you need to understand, and he needs to understand, is opto-isolators work at a circuit board level. They are not going to eliminate noise at distance. And that simply means that a cable is a component used when it's double shielded to mitigate noise at both high and low frequency over distance. That is the biggest misconception I've heard lately, is guys think an EMI filter will filter their cables, running 10, 20 feet. The cable itself is carrying the signal away from the source. The EMI filter is going to filter at the source. It's not going to necessarily filter at a range that will be effective when we go great distances. So keep that in mind. Think of an EMI ferrite. They're effective over short duration, but they're not going to be as effective the farther away from that magnetic field. This is fact. This can be researched, once again, which of course he would have known had he done it.
Outside of the box, there was more work to do. I designed the motor connections in such a way that they could be easily unplugged and swapped out if need be, by using terminal blocks for the contacts. From there, I ran wires up to the plugs that connected to the control box. Now, I'd originally used some cheap 4-conductor cable that I found on Amazon, but unfortunately the low price came with some complications. I didn't realize this at first, but when the machine became bogged down under a heavy load, the increased power draw must have been creating noticeable electromagnetic interference, which was getting picked up somewhere in the limit switch lines and causing a false positive. This caused the machine to stop sometimes, but eventually I replaced all of the motor and switch wiring with shielded microphone cables, which seems to have solved the issue.
Once again, another prediction I made came true. What I just explained about the noise he experienced with his system, and what's really interesting is he really defines that he just throws things at the wall, see what sticks, and again, always looking at price in the interim instead of saying, well, what's it going to cost to do this right so I'm not wasting time like you just saw him throw out cable, and I'm going to go back and then do the research. Guys, don't do it that way. Take your time, find the correct videos to watch, look at who you're learning from, see what history they have, what's their background, do your due diligence, don't spend money needlessly, don't use microphone cable for limit switch use for robotics. It's not designed for that. Buy what needs to be done and do it right the first time. Okay, guys, in this portion of the video, this individual makes another follow-up video, and a lot of guys do that because they see the opportunity to correct mistakes on top of getting free content because it keeps you watching. Well, this is interesting because I was thinking that he was going to do this video and actually show that he learned a lot, went back and researched and wanted to correct some of what he did. Let's watch what he actually does.
It's been quite a while since I bought most of the parts for the machine, and I didn't save all the receipts, so I can't really give an exact number. Now, I'd roughly estimate, based on what I can remember, that for the machine itself, including all the electronic and mechanical components.
Once again, this end user wants to make a quick point about how proud he is he spent the $1,000. What he's not discussing is how much additional money and time he spent troubleshooting and refurbishing a robot that, if built correctly with the correct knowledge implemented the first time, he would have saved. Guys, be very careful. A production robot that cheap usually means corners are cut. You've seen it in the video.
I think I spent about $1,000. Now, I did get some really good deals on a few things, particularly the aluminum plates and extrusions. The 3/8 or 10mm plate, for example, I found at a local industrial surplus store. Something like that would have cost a lot to ship due to the size and weight, but
We don't have any talk yet on any of the electronics. This is interesting. I'm sure he got questions on them. Let's see what happens.
about the wiring setup for the electronics. I'm no electronics engineer, so this may not be the best way to wire everything.
Okay, here's where I had to really think about whether I was going to do a video on this. And I have to say, I wasn't going to do it originally because he said this. The question is, why would you say this on a second follow-up video and not the initial video where you disclose how you built the system and the electronics? It doesn't make any sense. The other thing that I find very interesting is that after he goes through this portion of the video, he continues to still spread misinformation. There needs to be accountability, guys. If you're going to say 1 + 1 is 4, somebody should be calling you out on that. And unfortunately, what we're seeing now is this DIY attitude that, hey, it's okay to post for content to get more and more subs, but it's not okay if you're hurting people in that they're going to use that information to hopefully build a system for themselves and think they're doing it right, which they may not be, and in this case they're not. I've said this in all my previous videos. If CNC operation was as simple as connecting leads from point A to point B, there would be no forums. This individual needs to understand, stay and do what you understand fully. That's all there is. He's got great content like many of them do. They just seem to want to delve into areas that they don't truly understand.
But here's a quick diagram of how I set everything up. This is a diagram that I put together to hopefully help some of the people that had questions about the wiring.
Okay, we still see a general wiring diagram missing the proper double shielded cable, which he himself had issues with his limit switches. So he never really went down that rabbit hole of understanding why EMI affects these systems so much. He never really did any research on the Arduino. He would find out about that too. There's many articles out there on how the Arduino is not stable for CNC use. I'm telling you guys right now, the misinformation continues with just guys providing a basic component wiring diagram. This is why most end users find me, is because when they use these diagrams, yes, they get general motion for periodic use. They don't get motion under a stable platform for production use.
So the image that you're looking at right now is a schematic for all of the wiring, not including the wires that go from the drivers to the motors. Those are pretty self-explanatory. Basically, the ground and voltage.
Okay guys, I'm inside of a lead shine closed loop stepper motor, aka a servo motor. Servos once again use encoders to dictate where their shaft's position is to prevent them from missing steps. And why I say prevent, they do not guarantee a misstep. Let me explain. Any motor that's run outside of its normal operational envelope will be inaccurate regardless of whether it's a servo or a stepper. That's fact. Secondary piece of information most missed online when discussing CNC electronics is right here in the user's manual, where it states shielding control and signal wires is suggested, and then underneath that, to avoid/reduce interference, do not tie control signal cables with the power cables/wires together. Now once again, I'm going to scroll up and you can see this is their integrated closed loop stepper motor, aka servo. So guys have a lot of interpretations where they feel that because the motor has an encoder, it's not susceptible to EMI. I hear that a lot. It's incorrect, guys. EMI can screw up signals regardless of what piece of electronics you're using. It's fact. Okay? And EMI is present anywhere electronics are. The next thing is, if we come over here to a lead shine stepper drive, this is a stepper drive, not a servo drive, you can see that in their user's manual, it states the same thing. Number 1, shielding control signal wires is suggested. Number 2, to avoid interference, don't tie pulse and direction control signal and motor wires together. Okay? The thing you need to keep in mind is this. Always when you're building a system, and for my novice guys out there, this is one of the toughest lessons to learn because it incorporates spending more money. Fact. If you're buying a $30 drive and you're buying a $40 power supply, each drive you need one drive typically for each axis. And when you need that, And most guys understand that, and they see these Chinese kits put together. They think, oh, for $150, I built a controller. No, you've just started, sir. If you want to build a controller, you also need those cables. And by the time you're done with all the cabling and you're done with all the proper filtering that has to go into a controller, you start seeing that price go up exponentially. That's where guys usually get sticker shock. And that's where they tend to do one of two things. Either avoid the cables altogether and avoid building the system correct altogether and just plug wires in, which we see most YouTubers do, especially in my series, and then they have problems later and they end up repurchasing or rebuilding or just replacing the controller in general. Or you go back and you look at, hey, I'll wait and I'll save and I'll do it right. Educate yourself with the right people, guys, and do your research. I'm not even asking you to believe me. If I am telling you this, I'm just drawing your mind to ask questions. Usually the more questions you ask, detail will come out. Detail exposes everything.
That comes from the power supply, goes into those connectors, and then the A+, A-, B+, and B-, those are the 4 wires that go to each motor. And the rest of this basically describes how the Arduino connects to the pulse, direction, enable, and the switches, which are connected through the limit switch isolator board. So if you want, now would be a good time to pause the video, maybe take a screenshot. I'll also put a link in the description to this image if you want to reference it later. The opto isolator board is optional, and I'm not even sure it does much, because I still had issues with electromagnetic interference.
He still had problems with electromagnetic interference and had to switch over to shielded cables, yet he never disclosed it in his wiring diagram.
And had to switch over to shielded cables. If you want to know more about how to set up the wiring properly for an Arduino-based setup, head over to the GRBL site where they have extensive documentation on this.
Okay, guys, I want you to think about this for a minute. He's directing you to an Arduino site about doing the connections in which he made. Well, it's funny because where it says here, connecting normally closed end switches to Gerbil, improved noise filtering, again, this is where he got his information from, and he encountered problems. Why would you use a site that you've already encountered problems yourself and use that as a point of reference to send others to? It just doesn't make any sense to me. I know it won't make much sense to you. These are the questions I have with these people spreading misinformation. There's just no logic here.
Look into using a different control board instead of an Arduino. Arduinos just aren't that powerful, and the firmware that runs on it, GRBL, just doesn't have as many features.
Okay, guys, I'm sure you realize that the last frames that we just discussed the Arduino and him sending you over to their site to use as reference, now he's telling you consider using a dedicated CNC controller. This he posted in the video after describing where to get the information on the Arduino as if to direct you towards using it to build your system. Once again, I'm lost here as this really does not make any sense logically.
The next upgrade would be to use closed loop steppers or servo motors instead of the open loop type ones that I used. Closed loop systems provide feedback on the physical position of the shaft after every step, so losing steps just isn't really an issue. This leads to improved precision.
I want to point out, this is another misinterpretation we see online all the time. I am not stating this. You can see this is Oriental Motors website. It says here, servo motors, which has better accuracy, stepping motor or servo motor? Accuracy for both is the same. The method of achieving high accuracy for a stepping motor and the servo motor are different, but the outcome is the same. Now, if you want to read about it, we just covered it. It's the same thing, guys. And I'm going to prove this once and for all because I'm going to ask you all a logical question. Many of you realize 3D printing has been around forever, and it's getting more and more popular. And the thing is this, 98%, probably 99% of the 3D printers that are on the market use steppers. I have a $6,000 MakerBot method, and it uses stepper motors. But guess what? It has an accuracy of 0.02 of an inch printing ability with a patent on it. So I want you to think about that for a minute. Think about the fact that when we 3D print, we don't sit and go back and forth with steppers or servos. But the accuracy of our prints, you see guys achieving the same accuracy whether it's a servo or a stepper. If you really want to discuss where the benefits of a servo come in, it really comes down to what chassis you're mounting it on and what you're actually doing with that chassis. If you're running a Haas mill, and I've said this before, servos are probably going to be your better fit. If you're running a personal mill, steppers are definitely going to give you more bang for your buck. Servos were typically used in more commercial environments due to the fact that it would offer a larger platform of profit for the end user. Yes, they have benefits in speed, but not always, especially as we see newer technology come out where we see more of the hybrid stepper motors. Now we're seeing drives that can go up with higher micro stepping, higher speeds, less vibration. We see that all the time. Gecko Drive releases all kinds of drives, lead shine. You can go on and on. The bottom line is this. It's what is your budget, and an inch in measurement or 1 millimeter in measurement never changes. So whichever motor will go to that same exact measurement, you've already achieved half of it. Now we just apply that to the substrate of what you're cutting, and whether it starts with a circle or ends with a square, as long as it comes out dimensionally correct, you're there. If you want to go faster, that's fine. Most of my guys realize that going faster doesn't necessarily dictate better. Speed is good only if accuracy comes first. Always remember that. And that wraps up part 11 of the series, guys. Once again, I want to thank you all for your support. I hope you are learning something with these videos. And once again, do your due diligence, be careful, spend your money wisely. Thank you all. Take care.